Imagine you are finalizing your class schedule. You have to pick one teacher for maths, you have a choice of two for law, and three for accounts. Trying to map out every possible schedule by hand quickly becomes a tangled mess. Permutations and combinations serve as the mathematical shortcuts that allow us to calculate these totals without drawing a single line. The system is built on two primary logic rules. First is the AND rule. When you have to complete multiple independent tasks, like choosing one of three entrance doors to enter a building and choosing one of two exit doors to leave, you multiply your options. 3 times 2 gives us 6 distinct paths. The second is the OR rule. If you have a choice to do either one task or another, you add your options together. These two rules act as the primary building blocks. As we move into more restrictive problems, we'll see how these operations form the basis of the entire counting system. To choose the right math for a problem, we first identify the goal. On the left, we have a permutation. This is an arrangement where the specific order determines the outcome. If your phone password is 123, entering 321 in the wrong order fails to unlock the device. On the right side, we have a combination. This is a selection where order doesn't change the result. If you pull an apple and a banana from a fruit bowl, the snack is the same whether you grab the banana first or the apple first. We solve permutations using the box method. To build a 4-letter code from 10 available letters without repeating, the first box has 10 options. Without reuse, the next has 9, then 8, then 7. We multiply them to find total arrangements. Combinations are trickier because we have to remove duplicates. If we select a team of 2 from 5 people, the box method gives us 20 pairs. But since John and Mary is the same team as Mary and John, we divide by 2 to avoid overcounting. The C formula handles this division, ignoring internal order. Many problems will add a specific condition or constraint to the mix. The most efficient way to solve these is to lock that condition in first, then calculate the remaining variables. To create a 6-digit telephone number starting with 9, 8, and 7, those first 3 boxes are locked. Being predetermined, they each have one option. We filled the remaining 3 boxes from our available pool, reducing choices as we go. Handling the constraints at the start prevents the specific conditions from cluttering the rest of your calculation. The zero trap. Building a 3-digit number from 0 through 5 with repetition. The hundreds box cannot be 0, creating a 2-digit number. This leaves 5 options. The remaining boxes have 6 options each. 5 times 6 times 6 totals 180 valid numbers. For the together rule, arranging stadium with vowels together means bundling A, I, and U into one block. This block plus 4 consonants makes 5 units, arranged in 5 factorial ways. The 3 internal vowels arrange in 3 factorial ways. Multiply these for the total. This macro and micro approach ensures we account for every possible movement, both for the group and for the individuals within it. To see how these rules work together, let's solve a 2-step problem. We will form a 5-letter word by selecting 3 consonants from a pool of 7 and 2 vowels from a pool of 4. First, we select our letters. Since we are just pulling them from a pool and haven't placed them in order yet, we use combinations. We multiply the consonant selection by the vowel selection. Now that we have 5 letters chosen, we need to arrange them into a word. This adds the element of order, so we multiply our selection by 5 factorial. This 2-step process brings us to a total of 25,200 words. This cheat sheet summarizes the logic. Use the AND and OR rules to set your math. Identify whether you are building a ranked arrangement or a simple selection. Address your zeros and grouped items by their specific rules, and you can break down any counting problem into its component parts. Once you recognize these patterns, the complexity of counting disappears. Take a look at the practice sheet to apply these rules yourself, and I'll see you in the next lesson.